Hi everyone, my name is Alina Selega, and here is a short overview of our recent paper published in TMLR and presented in the AUTOML journal track. Our method is designed for Bayesian optimization over multiple objectives, some of which may not be useful for optimization, and it adaptively weights each objective based on desirable characteristics of the posterior functions. We focus on the case with many heuristic objectives that approximate the true unknown meta-objective, but not all of them may be useful in terms of aligning with the meta-objective with respect to their maxima. This is a scenario that frequently arises in hyperparameter optimization for biomedical data analysis. Let's say we have a workflow that analyzes some data by a sequence of steps, and we want to optimize the hyperparameters to get the best results as measured by some objectives. Typically, there is no ground truth available, so we have to instead use some heuristic measures, and many choices are possible. Also, unexpected failures in the data generating process can render some objectives uninformative, and we want to know this up front. We address this with our method that automatically infers which objectives are useful during optimization. We introduce the concept of a desirable behavior that describes what a useful objective should look like. These behaviors can be computed from the posterior fit to data at every optimization step. And then we compute the probability that an objective is useful given its behaviors, and use these to upweight useful objectives in the scalarization function. We suggest some example behaviors, for example, those that favor objectives that explain the data well, correlate well with others, and contain the maximum within the searched region of the parameter space. But ultimately, these behaviors are intended to reflect practitioners' expectations and are left to be user-specified. Hope to see you at our poster.